Did you know that tiny, resilient creatures known as water bears can survive in extreme conditions? But what if the real mystery lays in how they manage stress? You might think it's straightforward, just analyze the data, right? Here's the urgent twist: A is encountering unexpected challenges, revealing critical pitfalls in understanding these creatures' stress responses. Imagining a creature just a millimeter long, thriving in the vacuum of space. Yet, beneath this tough exterior, stress signals are intricately woven into their biology. Many people overlook these signals, assuming these creatures can handle anything that comes their way. But can they really? Now, picture yourself in a lab observing a model process a mountain of data. Suddenly, it misses vital emotional cues like a friend silently struggling. This oversight could lead to a catastrophic misinterpretation of their resilience, resulting in flawed conclusions. What's the hidden cost of this mistake? It could mean wasted resources, misdirected research efforts, and time spent on paths that don't even touch the truth. Think about the implications. What if the systems we rely on to understand resilience are fundamentally flawed? We could be missing crucial insights, and that's a chilling thought. So, what can we do? We need to approach water beer research with a fresh perspective. Let's embrace a holistic view that combines A with human intuition. This isn't just about crunching number sets, it's about understanding the stories behind the data. As you reflect on these insights, ask yourself, how often do you take a moment to step back and reevaluate your methods? The unexpected pitfalls of A could lead us to a deeper understanding of resilience, not just in water bears, but in our own lives. Are you ready to adapt and look beyond the surface? The warning signs are clear. Have you ever heard of water bears? These tiny, incredible creatures can survive in conditions that would obliterate most life forms. However, our fascination with them has led us into a maze of unexpected challenges. What if I told you that the very technology we use to study their remarkable resilience might actually mislead us? As the world rushes to harness A for groundbreaking discoveries, we are starting to see cracks in the surface. The challenges of using A to understand how water bears thrive are becoming evident, and they could have serious consequences. Are we truly interpreting the data correctly? Imagine relying on A to unlock the secrets of life, only to find it missing crucial details. Picture yourself in a lab, eagerly watching a screen full of data, convinced you are on the brink of a major breakthrough. But what if that confidence is misplaced? Research indicates that A can overlook subtle aspects of biological resilience, leading scientists down the wrong paths. This isn't just theoretical. What if the cures for diseases or solutions to climate change depend on our understanding of these tiny creatures, yet we're getting it all wrong? Every moment spent trusting this technology could mean missing vital insights. Are we ignoring the limitations of our own tools? Imagine an experiment that could change the world, but due to a detail overlooked by A, it leads to a dead end. So, what's the solution? What's the solution? Surprisingly, stepping back from complete reliance on A might be the key. A blend of human intuition and machine analysis could protect us from these pitfalls. But here's the catch: finding this balance is delicate and requires a shift in our thinking. As we move forward, are we prepared to confront the hidden risks beneath the surface? The next time you hear about the wonders of water bears, remember that the story doesn't end there. It's a call to dig deeper, ask more questions, and stay alert to the unexpected. If you found this intriguing, don't forget to subscribe and join the conversation about the mysteries that still await us. What if I told you that some of the toughest creatures on Earth might actually be misunderstood? Imagine these tiny, nearly indestructible beings thriving in the harshest conditions. But here's the twist: our attempts to understand how they survive might be missing the mark. You might think scientists have it all figured out, but there's a hidden danger in the world of artificial intelligence. In our quest to uncover the secrets of water bears, what if we're overlooking the bigger picture? This isn't just about tiny creatures, it's a cautionary tale about the potential pitfalls of fusing AI in biology. Picture yourself in a lab filled with cutting-edge technology where researchers are using AI to monitor the movements and behaviors of these fascinating organisms. Sounds impressive, right? But what if relying solely on AI could blind us to crucial behavioral details? While the algorithms are powerful, they often miss the subtle aspects of water bear resilience. When studying their behavior, the data can sometimes be misleading. Imagine spending hours observing, only to realize that the tiny details that matter most have slipped through the cracks. Does that make you question everything you thought you knew? Think back to a time when technology led you astray, maybe a navigation app that took you on a wild detour. That frustration mirrors what scientists face as they delve deeper into water bear research. With every data set they analyze, there's a risk of oversimplifying a complex reality. As they explore the genetic makeup of these creatures, the algorithms generate conclusions. But do they truly capture the essence of water bears? Picture a water bear curling up tightly when threatened. That instinctive moment might get lost in translation, hidden behind lines of code. Let's raise the stakes. What if the very tools designed to help us discover are actually leading us to misunderstandings? If AI continues to misinterpret behaviors, we could end up with a flawed understanding of not just water bears, but entire ecosystems. Imagine the consequences: conservation efforts based on incorrect data could falter, leading to irreversible damage. So, what's the solution? It's time